So in this video, I want to talk to you guys about the fundamental theorem of calculus, part 2. And basically what it tells us is how to calculate a definite integral. Okay, so if we want to integrate, this theorem says if we want to integrate little f of x from a to b, it says that we find capital F of x, which is the antiderivative. Then we calculate f of b minus f of a. Okay, so we take the upper limit of integration and subtract it from the lower limit of integration. So we're gonna actually put this into practice. We're gonna start with our first problem. We're gonna take the definite integral from 1 to 3 of x plus 2 dx. So this theorem states that first we take the antiderivative. So the antiderivative of x plus 2 will first take the antiderivative of x to the first. And the way we do this is we add 1 to the exponent and then divide by the new exponent plus the antiderivative of 2 and the antiderivative of any constant. All we have to do is just add a variable to the end of it. So this is going to be plus 2x. So here's our antiderivative, but then we have to integrate it from 1 to 3. So the way we do this is first we plug in 3 to our antiderivative. So this will be 3 squared divided by 2 plus 2 times 3. Then we subtract, we're doing this part right here, then we subtract f of a, which a is 1, so we're going to subtract 1 squared divided by 2 plus 2 times 1. If we so we're going to do some simplification. 3 squared is 9, so this is going to be 9 divided by 2 plus 2 times 3 is 6 minus 1 squared is 1 divided by 2, so this is 1/2 plus 2. Okay, so if we simplify this out, so this is actually, you can type this all into your calculator, but this is going to actually be equal to 8. And that will be the answer to this problem. So for our second problem, we're going to take the definite integral from 1 to 4 of the square root of 5 divided by x dx. And the first thing we need to do is we need to take the antiderivative of the square root of 5, or the square root of 5 divided by x. And the way we're going to start out by doing this is we're going to start out by rewriting this as the definite integral from 1 to 4 of the square root of 5 divided by the square root of x. Then we can further rewrite this to, since the square root of 5 is just a constant, we can bring it out to the front. So this is going to be equal to the square root of 5 times the definite integral from 1 to 4 of 1 divided by the square root of x dx. Okay, then we need to rewrite this again. The square root of x is just equal to 1 divided by x to the 1/2 power. But then in order to be able to take the antiderivative of this, we need to move the x to the 1/2 power to the numerator. And the way we do that is by switching the signs. Currently it has a implied positive out in front of it, so we're going to switch it to a negative. And if we rewrite all this, so this would be equal to 1 divided by x to the negative 1/2 power, which would be on top. So it would actually, yeah, so we'll just rewrite it over here. Okay, so the square root of 5 times the integral from 1 to 4 of x to the negative 1/2 power dx. Okay, so now we can integrate our function right here. So we're going to add 1 to the exponent, and that's going to bring us to x to the 1/2, and we're going to divide by 1/2. So this is going to be equal to x to the 1/2 divided by 1/2 But since we're dividing by a fraction, we have to multiply by the reciprocal. So we're going to, this is going to be equal to 2x to the 1/2. But we can't forget we have to multiply by our constant out in front. So multiplied by the square root of 5. And we're going to integrate this from a to b, so from 1 to 4. Okay. So we can actually rewrite the x to the 1/2 as x squared. So this is going to be the square root of x. So this is going to be 2 times the square root of x times the square root of 5 from 1 to 4. So just like last time, we're going to plug in a 4 in place of all of our x's. So this is going to be 2 times the square root of 4 times the square root of 5 minus, then we're going to plug in all our 1's, 2 times the square root of 1 times the square root of 5. If we do some simplification, the square root of 4 is 2, so 2 times 2 is 4. This will be 4 times the square root of 5 minus, the square root of 1 is just 1, so this will be 2 times the square root of 5. And this is our answer, but we can actually further simplify it by subtracting our coefficients, 4 and 2. So this will be, in simplest form, 2 times the square root of 5. Actually, if you wanted it a little bit more simple, you could actually type that into your calculator and get a number, but since I can't do that in my head, this will be the simplest answer that I can give you. Okay, that's the answer to this problem.